My name is Adam Albar, and I will be doing the first question for the final video submission. So in this question, I will be calculating the yield curve for the different maturities given and the price of the risk-free bond with a face value of 1,000 and a coupon rate of 10%. So in order to find the yield to maturity, we first must use the yield to maturity equation, which is yield to maturity equals face value divided by price, and then powered to the 1 divided by years to maturity, and then subtracted by 1. So knowing that information, for year 1, we would do the face value of 1,000 divided by the current price, which is 925.15, divided by 1 divided by, or 1 to the 1 minus 1, which would give us 8.9%. For year 2, we would do 1,000 divided by 862.57 to the 1/2 minus 1, which will equal 7.71%. For year 3, we would do 1,000 divided by 788.66 to the 1/3 minus 1, which would give us 8.2%. And for year 4, we would get 1,000 divided by 711 to the 1/4 minus 1, which would equal 8.89%. So now that we have all of our yield to maturities, we are now going to find the price of a 4-year maturity bond with a 10% annual coupon. So in order to do this, we have to use the question where we do our coupon payment, so 10% of the face value divided by 1 plus our yield to maturity for the year powered to the year number, and then add those all up together. So that would look like 100 divided by 1 plus 0.0809 to the 1 plus 100 divided by 1 plus 0.0771 to this squared, plus 100 divided by 1 plus 0.0820 to the third, and then plus, and for this one we would do 1,100 instead of 100 because the bond is paid fully at the year end, which is because it's 4 years, and then divided by 1 plus 0.0889 to the 4th. And this would give us a final answer of 939.86.
Hey, my name is Connor Rich. I have the last 2 problems on our bond homework, and I'm going to get started. So for the first question, we have a bond that's set up. It's got 4 payments, each payment of $30, and the last payment is the one where you get your face value back. So it's going to be $1,030. We know the market data says the yield is 5%, so we have our periods, we have the payment that we're getting, and we have the yield. So what they're looking for both of these situations is duration. And the way we're going to start to find duration is we need to find the discounted payment of each payment. And what that means is we need to find the present value, which just uses a basic present value formula of the future value divided by 1 plus the rate to whatever power you need to go to. So I'll do the first one, for example. It's a $30 payment. And remember, it goes 30, 30, 30, 1,030 for each payment. So it's going to be 30 over 1 plus 0.05. That was the market data yield, in parentheses to the first power, and you're going to get 2857. You're going to do that for every single one of them all the way down, and you're going to add them all together, and that's going to be $929.08. And what that represents is the net present value of the bond. What is the bond worth right now through time? So that last value is important because to find the weight, you need that price. So to find the weight of each payment, you're going to do the the present value of the payment divided by the total price. So for the first example, we used $28.57. We're going to divide that number by the 929.08, and we're going to get a weight of 0.0375. And what that represents is just the weight in the total price. You're going to do that for all of them, and then you're going to multiply that weight times the payment it's in. So if it's in the first payment, you're going to multiply 1 times whatever weight you got. Second payment, you're going to multiply 2 times whatever payment you got. And you're going to add all of that together, and that's going to be 3.821. What that represents is duration, saying in X amount of periods, this is how fast you will make your money back. And so this is a payment bond, or they think you're going to make your money back in 3.821 payments. And now we're going to get to the second one. Very, very similar. It's just a little bit different. The numbers are different. The face value is always 1,000. Coupon rate is 7%. YTM is 5%, and the N is 6. Last time it was 4. Now it's 6. So first we need to find the payment. We know the coupon rate is 7%. We know the face value is 1,000. We're going to multiply those two together. And we're going to get $70. That is going to represent each payment, and then remember on the last payment you get the face value back. That's going to be $70 for each payment, and then $1,070 for the last one. So remember, first we got to start with our time value function. We're going to take that all back, and then add all the whole time value together, and we're going to get $1,101.51. Then we need to find the weight of that. So go and take the time value you found for each period, divide that by the total price. You're going to get your weight for each one of them. Then you're going to take that weight and multiply it by the payment you're in. So if you're in the first payment, take that weight and multiply it by 1. You're going to add all of those numbers together, and what you're going to end up getting is 5.147. And that represents your duration. Saying in a 6-payment bond, you expect to get your full money back in 5.147 payments.
Hi, I'm Matt Foreman. I'm going over questions number 3 and 8 for the video submission. So question number 3 is asking us what treasury strips are, and then we're given different qualities, and we're tasked with finding the correct one that matches up. So the correct answer is that treasury strips are created by selling each coupon or principal payment from a whole treasury bond as a separate cash flow. This is because treasury strips are created by separating the interest payments and the principal repayment of a standard treasury bond, and you're splitting each of those into individual securities. And then those individual securities are sold separately as a zero coupon bond. So then we can also go through and why the other answers are incorrect. So for securities issued by the Treasury with very long maturities, that's incorrect because they're not issued by the U.S. Treasury as complete securities by the U.S. Treasury. They're created from already existing Treasury bonds. So they're not created, they're just used from already existing. And then the other one is they're extremely risky securities. And this is wrong because the treasury strips are backed by the U.S. Treasury securities, so makes them more safe and less risky because they're backed by the U.S. Treasury Department. And then there's also created by pooling mortgage payments made to the Treasury. This is wrong because that's describing mortgage-backed securities, not strips. But like I said earlier, strips come from Treasury bonds, not mortgage loans, which is what MBS or mortgage-backed securities do. They come from mortgage loans. And then obviously the answer is none of the options are correct because we identified the correct answer above. And then I also did, we can also look at number 8. So number 8 is asking us to find the yield to maturity on a 3-year coupon bond. And we're given a table with the maturity and price over 4 years, and then we're also given the par value of 1,000. So this one's really easy. We're just using the yield to maturity equation, and the yield to maturity equation is equal to the face value over the price, and that's in parentheses, and then to the power of 1 over n is equal to the number of periods, and then that is minus 1. So when we plug in our numbers given, we were given a face value of 1,000, so it'll be 1,000 divided by $788.66. And we find that just by going to the table and looking at the maturity of 3 years and the price that matches up with it. So we do 1,000 divided by $788.66 to the power of 1 over 3, and then 3 is because we're solving for the yields maturity on a 3-year coupon bond, and then that's minus 1. So when we do that, we get 8.24%, and then that's one of the answer choices they give you, so you know it's correct, and that's the final answer.
My name is Rory Arnold. I'm a finance and entrepreneurship major. I have the question after 8. It's not scored numerically. It just says question. So I don't know which question it is, but the question reads, for the problem below, first calculate the yield to maturities, then the price of the coupon bond, and then calculate the yield to maturity of the coupon bond using the rate function. So we're given 3 years for the maturity, and then 3 different coupon bonds at $1,000 par bond. So it's 0 coupon also. And then what we need to do is find the yield to maturity equation, which is just future value divided by price to the power of 1 divided by the yield to maturity year minus 1. And so for the first 0 coupon bond with 1 year maturity, the price is $943.40. And so we take 1,000 divided by 943 and then 40 cents divided by 1 to the 1 because it's year 1 minus 1, and we get 0.05999,576%, which rounds to approximately 6%. The second year bond with a 2 year maturity, we have a price of 873.52, and we do 1,000 divided by 873.52 to the power of 1 divided by 2 minus 1, and we get about 6.995022%, which is 6.99% to be precise. Third year coupon bond has a 3 year maturity with a price of $816.37. Do 1,000 divided by 816 and 37 cents to the power of 1 divided by 3 minus 1, and we get 6.99% again. And then for using the rate function for the 0 coupon bond in Excel, we're going to take the rate and then the time, 0, the price of the bond, but make sure the price, since the present value, it has to be negative, and then the future value, which is just 1,000. And so the time is just also the number of periods. So year 1 is 1, year 2 is 2, year 3 is 3, just because the maturity rate. And we have no periodic payments, so that's why the payment is 0, hence a 0 coupon bond. And that is all that I have, because you just do the same formula again. So for the second bond, it'd be negative 873.52, because that's the present value, and third bond, negative 816.37.